If you've ever thought Bitcoin seems complicated, like you need a degree in computer science just to get it, I'm here to tell you that's not true. It's actually way simpler than you think. Today, we're going to break down exactly how Bitcoin works, in a way that anyone can understand. So, let's dive right in. All right, before we get into the nitty-gritty, let's do a super quick recap of what we covered in the last video. Remember, Bitcoin is basically digital money. You can send it to anyone, anywhere in the world, without needing a bank or any middleman. It's built to be secure and decentralized, meaning no single person or company controls it. All of this magic happens on something called a blockchain. You don't need to be a tech expert to use it, just like you don't need to be a mechanic to drive a car. If you missed that first video or need a refresher, feel free to pause right here and go watch it. I'll be here when you get back. So, how does a Bitcoin transaction actually work? Let's imagine a simple scenario. Alice wants to send 1 Bitcoin to her friend, Bob. She initiates the transaction right from her digital wallet. Notice there's no bank involved here. Once she hits send, her transaction request is broadcast out to the entire Bitcoin network, a huge web of computers all around the world. These computers, which we'll talk more about in a minute, work together to verify that Alice actually has the Bitcoin to send. They check to make sure she isn't trying to spend the same coin twice, which is called double spending. If the network tried to approve a double spend, it would be rejected immediately. Once everything checks out, the transaction is confirmed and bundled together with other transactions into what's called a block. This block is then permanently added to the blockchain. Now, Bob officially has the Bitcoin. It might sound like a lot of steps, but it's an incredibly streamlined process. Feel free to pause and rewatch this part if you need to. It's a core concept. Okay, so I keep mentioning this thing called the blockchain. What is it? The easiest way to think about the blockchain is as a giant public digital ledger. Imagine a notebook, but instead of being owned by one person, an identical copy is shared with every single person in the network. Each page in this notebook is a block, and each block is filled with a list of verified transactions. Once a block is filled up, it gets added to the end of the chain, creating a chronological record. Here's the most important part. Each new block is cryptographically linked to the one before it, forming a chain. This link makes it incredibly difficult to change or tamper with any information once it's been recorded. You can't just go back and erase a transaction. Because everyone on the network has a copy of this ledger, everyone can see the same history of transactions, making the whole system transparent and trustworthy. So, who are these computers that are verifying all the transactions? This is where miners come in. When you hear about Bitcoin mining, don't picture people with pickaxes. Instead, think of miners as super powerful computers specifically designed to do one thing: solve complex mathematical puzzles. When Alice sends her Bitcoin to Bob, miners all over the world compete to be the first one to solve the puzzle associated with that new block of transactions. The first miner to solve it gets to add the block to the blockchain. As a reward for their work, for using their computing power and electricity to keep the network secure, they are rewarded with a small amount of newly created Bitcoin. You can think of miners as the referees of the Bitcoin network. They enforce the rules, confirm the transactions are legitimate, and get paid for keeping the game fair and running smoothly. Now, you might have heard that a Bitcoin transaction takes about 10 minutes to be confirmed. Why so long? It's not because the network is slow. In fact, it's by design. The mathematical puzzles that miners are solving are intentionally difficult. The Bitcoin protocol automatically adjusts the difficulty of these puzzles to ensure that, on average, a new block is found and added to the blockchain roughly every 10 minutes. This 10-minute interval acts like a speed limit for the network. It keeps things stable and predictable. It gives the network enough time to process thousands of transactions securely and make sure all the copies of the ledger across the globe are synchronized. This deliberate pacing is a key feature that helps maintain the network's integrity and security, preventing a chaotic free-for-all and ensuring every transaction is properly validated before being permanently recorded. This brings us to the big question. What makes Bitcoin so secure? It's all about decentralization. Remember how everyone on the network has a copy of the blockchain? That's the key. The entire transaction history is stored on thousands or even millions of computers spread all across the world. For a hacker to cheat the system, say by trying to reverse a transaction or create fake Bitcoin, they would need to simultaneously attack and take control of more than half of all the computers on the network. This is known as a 51% attack. Given the sheer size and global distribution of the Bitcoin network, pulling this off is practically impossible. It would require an astronomical amount of computing power and resources, making it a completely unfeasible task. It's like trying to change a word on one page in millions of identical notebooks, all at the exact same time, without anyone noticing. The decentralized nature of the blockchain is its greatest strength. All right, let's do a quick visual summary to tie everything together. It all starts with a transaction. Alice decides to send Bitcoin to Bob. Her transaction is broadcast to the network. Next, the miners, those powerful computers, get to work. They compete to solve a puzzle and verify the transaction. Once verified, the transaction is included in a new block. That block is then added to the blockchain, the public digital ledger, which takes about 10 minutes. Finally, because the blockchain is distributed across thousands of computers worldwide, the entire system remains incredibly secure. The end result is a system that is trustless, meaning you don't need to trust a central authority, decentralized, meaning no one entity is in control, and transparent, as anyone can view the ledger. I hope that breakdown makes how Bitcoin works a lot clearer. The technology is brilliant, but the concept is something we can all grasp. If you found this helpful, it would mean the world to me if you hit that like button and subscribe to the channel. And don't forget to ring that notification bell so you don't miss our next video. Do you have any questions? Did this finally click for you? Let me know in the comments below. Thanks for watching, and I'll see you in the next one.